Hello and welcome to another WJEC A level physics question. This time is question 5 from January 2011's PH2 paper. It's a question on the photoelectric effect. We're asked in part A to define the work function of a metal. Well, what we're going to say here is that the work function is basically the minimum energy required to liberate an electron from the metal surface. This is a common question, comes up in lots of these photoelectric effect past paper questions. The work function of sodium is 3.8 times 10 to the minus 19 joules. We need to use Einstein's photoelectric equation to find the lowest frequency of light which will eject electrons from the sodium surface. This lowest frequency is known as the threshold frequency. Well, Einstein's photoelectric equation is EK max is HF minus phi. And if we have electrons just barely emitted from the surface of the metal, then EK max will be 0. So this equation becomes 0 equals HF minus phi, where F this time we would normally write as F0, the threshold frequency. And if we rearrange that last equation, we will get that the threshold frequency is phi over h. So we have 3.8 times 10 to the minus 19 over 6.63 times 10 to the minus 34. When we put that into the calculator, we get 5.73 times 10 to the 14 hertz. For the second part of the question, we've got to find the maximum kinetic energy of the emitted electrons when a frequency of 7 times 10 to the 14 hertz is shown. So here we can just use the full equation. H 6.63 times 10 to the minus 34 again. This time the frequency is 7 times 10 to the 14. And we subtract the work function of 3.8 times 10 to the minus 19 joules. And that gives us 8.41 times 10 to the minus 20 joules. Now the answer to part B2 is unaffected by the intensity of light. So what they're saying is if we increase the intensity of light, you might expect that the electrons would escape with a greater energy, but in fact they don't. And we've got to explain this in terms of photons, why this should be the case. Now increasing the intensity means more photons per second. But those photons have exactly the same energy. Remember that the energy of a photon is HF. And another very important point here is that electrons can only absorb one photon. So no matter how many photons are hitting the surface per second, if the energy of the individual photons hasn't changed and electrons can only absorb one photon, then the maximum kinetic energy of those emitted electrons is not going to change. Part C2, what aspect of photoelectric emission is affected by the light intensity? Well, this would be the number of electrons that's emitted per second. In other words, what we would call the photoelectric current. Final part of the question gives us a standard apparatus for determining the maximum kinetic energy of the emitted electrons, and we're asked to describe how we would check our answer to B part 2 using this apparatus. So basically step 1 is sort of implied in the diagram, is you shine the light onto the sodium surface. increase the PD using that variable power supply. Until the ammeter reads 0. So what's happening here is, as we increase the voltage here across our photo cell, the sodium surface is becoming more and more positive. It's attracting the electrons that are trying to escape from the surface with a stronger and stronger force, if you like, until eventually, if the voltage is big enough, the electrons can no longer escape from the surface there, in which case they won't reach this collecting electrode, this little dot on the right hand side of the diagram, and therefore the ammeter will read 0. At that stage, we know that the work done by the electric field is equal to the amount of kinetic energy of the electrons. The electric field has removed the kinetic energy of those electrons. So what we finally do, once we've measured that stopping potential, so let's write that down, record the stopping potential, all we need to do is multiply the stopping potential Vs, let's put that in brackets to make it clear, by the electron charge E, and that will actually give us the maximum kinetic energy. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.